This video is on rotational kinetic energy and conservation of energy, and it's chapter 13-3 in the textbook. Okay, so if you imagine, remember kinetic energy is the energy an object has because it's in motion. So if you think about an object that's rolling or rotating, so imagine a tire that's spinning around, well, you could think about the little bits of the object are moving, and so hence they're going to have kinetic energy. So in principle, we don't really need a new kind of kinetic energy since it's just motion, and you could take all your little bits, and for each one of those little bits you do 1/2 mv squared to get the kinetic energy, and you just add it all up. In practice though, it's easier to define something called rotational kinetic energy. And in fact, what you do is exactly this trick. So you divide it up into little bits, then you add everything up, and what you find actually is that it's actually, so you end up doing an integral, and if you simplify things a bit, you can get that this rotational kinetic energy is 1/2 I omega squared. So, and this is actually pretty easy to remember. Remember, translational kinetic energy was 1/2 mv squared, and moment of inertia I plays the role of mass when we're talking about rotational motion, and omega, the angular speed, plays the role of the regular speed v. So now, if we're using conservation of mechanical energy, so we don't have any dissipative forces like friction, then the rotational energy must also be included. So if you take your translational kinetic energy initially, plus your rotational kinetic energy initially, plus the potential energy initially, that has to equal the final translational kinetic energy plus the final rotational kinetic energy plus the final potential energy. Now, if you want to do conservation of energy, so you do have some work done by external forces, you do possibly have dissipative forces, then basically this is just another term that needs to get added. So you need to add both kinds of kinetic energy, translational and rotational, the potential energy and the work, and that has to be equal, at any other point, right? So it's plus, any change in the internal energy of your system.